Planetary Nebula. When a star between 1 and 8 times the mass of the Sun exhausts its core hydrogen, it swells into a red giant and begins burning helium. The outer layers, no longer held by radiation pressure, drift away over thousands of years into an expanding shell of ionized gas. What remains at the center is a hot, dense core called a white dwarf, which will cool for billions of years until it fades into darkness. Type 1a supernova. A white dwarf in a binary system can steal mass from its companion star. When it accumulates enough material to approach 1.44 solar masses, a runaway thermonuclear reaction ignites throughout the entire star simultaneously. In a second pathway, 2 white dwarfs in a close binary spiral inward and merge, pushing the combined mass over the stability limit and triggering the same detonation. The resulting explosion is so uniform in brightness, it is used to measure cosmic distances, and it leaves nothing behind. Core collapse supernova. Stars heavier than about 8 solar masses build iron cores through successive rounds of fusion. Iron releases no energy when fused, so when the core exceeds the Chandrasekhar limit, it collapses in under a second. The infalling outer layers rebound off the newly formed neutron star in a shock wave that blows the star apart, releasing more energy in that moment than the Sun will produce in its entire lifetime. Electron-Capture Supernova. Stars at the narrow threshold between 8 and 10 solar masses produce oxygen-neon-magnesium cores instead of iron. When these cores grow dense enough, electrons are captured by magnesium and neon nuclei, removing the pressure that supports the core and triggering rapid collapse. The mechanism is distinct from iron core collapse and less energetic, but the result is the same, a neutron star and an expanding remnant. Hypernova. The most massive and fastest rotating stars collapse with enough angular momentum to form an accretion disk around the newborn black hole. 2 narrow jets of plasma punch through the collapsing star at near light speed, producing a gamma-ray burst visible across the observable universe. The explosion is roughly 100 times more energetic than a standard core collapse supernova. Direct collapse black hole. Some massive stars fail to produce a visible supernova at all. The core collapses as normal, but the shockwave stalls and is reabsorbed rather than escaping. The entire star disappears into a black hole with no explosion, emitting only a brief infrared or X-ray transient. Astronomers have observed candidate events where stars simply vanished from view with no preceding burst of light. Pulsational Pair-Instability Supernova. Stars between roughly 80 and 130 solar masses are massive enough to trigger pair production in their cores, but not massive enough to be destroyed in a single event. The resulting instability drives explosive eruptions that expel the outer layers and briefly brighten the star before the cycle resets. This can repeat over decades or centuries, stripping mass with each pulse. Eta Carinae is a living example of a star in this phase. The star eventually dies in a terminal collapse, leaving a compact remnant rather than being fully disrupted. Pair-Instability Supernova. Stars between roughly 130 and 250 solar masses die through a mechanism that leaves no remnant. At extreme core temperatures, gamma-ray photons spontaneously produce electron-positron pairs, reducing radiation pressure and triggering implosion. The temperature spikes high enough to ignite explosive oxygen burning so violent it completely disrupts the star. There is no white dwarf, no neutron star, no black hole. The entire mass is expelled into space. Red Dwarf Fade. The most common stars in the galaxy do not explode. Red dwarfs burn so slowly and mix their fuel so completely that they will outlive every other stellar type by orders of magnitude. After trillions of years, a red dwarf exhausts its hydrogen and contracts into a helium-white dwarf without ever passing through a red giant phase. No such remnant has ever been observed. The universe is not yet old enough to have produced one. Thanks for watching. If you enjoyed this video, then be sure to check out my other videos. Also, remember to hit that like and subscribe.